Good day. Today, we'll be sharing insight our smartphone codes as a team. Before we dive to our topic, let me introduce first my members, Baraya, Zero, Onsina, Duran, Ismenos, Ogaw, Ucias, Rapista, Santos, and Kabuyao, the leader of the group. But before we sharing our program, we proceed to explaining the Excel. First is the class name, which is the smartphone. This smartphone is the object of our program. Then next is the class field, which determine the attributes and the data of our object. First is the brand, model, storage, battery, volume, use storage, internet connection, and is music play. And after we declare the class field name, we proceed the sample data. These are the sample data of our class field. For the brand is null, model is null, storage is null, battery is 100, volume 100, use storage is 1 terabyte, and internet connection and music play is false. So after declaring the sample data, we we declare the data types of our class fields. First for the brand is the string and model string. Then storage, battery, volume, use storage is all int. Then the internet connection and music play is boolean. Then we proceed the class method, which is the behavior or the actions of the object. Then these are the switch power, internet password, menu, switch Wi-Fi, connect Wi-Fi, open camera, captured photo, display photo gallery, message, compose message, display message inbox, play music, open calculator, lock phone, create new phone, and display details. And after we explain the Excel of our program, we proceed to our program first. In the provided Java code snippet, we encounter the definition of a class named smartphone, meticulously designed to emulate the essential characteristic and function found in the typical smartphone. This class encompasses a comprehensive array of attributes including details such as brand, model, storage capacity, battery status, power state, power locking status, volume control, camera availability, storage usage, internet connectivity, and the state of music playback utilizing list it manage. Photo gallery for image storage, message for text box communication, and photo number for contact information. Notably, the code lacks the implementation of method for executing the fundamental smartphone actions, like phone capture or messaging, necessitating further development for practical functionality. The smartphone class as presented serves as fundamental framework for a smartphone model, awaiting an addition of methods to enable it perform the expected task of a real-world device. In this code segment, we encounter two distinct construction methods within the smartphone class, which play a pivotal role in the defining how instances of this class are created and configured. Catering to different model operating system, the first constructor designed for Android device is parameterized to accept three key attributes: brand, model, and storage. When this constructor is used, it initializes the smartphone's attribute based on the provided values. Brand and model parameters enable customizations of a device's brand and model name, while storage allow specifications of storage capacity. Additionally, default values are assigned to other attributes like battery level, volume, camera availability, use storage, internet connectivity, and music playback status. The second constructor, tailored for iOS devices, simplifies the instantiation process feature. I further in further it requires model and storage. Parami- Parameters and implicitly sets the brands and iPhone. Like the Android constructor, it's initialized the remaining attributes with the default value. This constructor Tors offer a structured approach to creating smartphones instances, making it convenient for configured devices for different operating system and use cases by providing initialized attributes value while maintaining default settings for unmentioned attributes.
So in this, so the next is the switch power. So the switch power method serve as the initial point of entry for powering on the smartphone. Upon execution, it graciously welcomes the user to the device by displaying the brand and model. Following this, it proceeds to print out detailed information about the phone using the print details method, providing insights into its current state. As you can see, the method also triggers the enter password function, which initiates the phone's unlocking process by requesting a password. The enter password method is responsible for overseeing the device security. It engages the user by soliciting a password input and then converts the entered password to an expected value, super shy. If the provided password matches, the phone unlocks with a reassuring message and proceeds to the menu method, presumably leading to the main menu. However, in the event of an incorrect password, it offers a prompt for re-entry and applies a recursive call to itself, providing the user with another opportunity to enter the correct password. These methods collectively form the core functionality responsible for powering on the smartphone and ensuring its security and interaction with the user. Next is So in this segment of the code, we encounter the menu method, an important component of the smartphone's user interface that comes into play once the device is unlocked. This method is carefully crafted to streamline user interactions and facilitate easy access to the device arrays of features, significantly enhancing the overall user experience upon execution. The method initiates by invoking the print details function, offering users essential phone information to establish context about the current state of the device. It then presents a comprehensive menu displaying a range of options including Wi-Fi control, camera access, photo gallery viewing, messaging, music playback, calculator functionality, and the ability to lock the phone. User choices are registered by entering a corresponding numerical value, which is subsequently processed through a switch gate structure. Depending on the selected option, the code smoothly guides the user to the relevant function, enabling actions like connecting to Wi-Fi or capturing photos. It's worth noting that option 7, which pertains to locking, is currently unimplemented in this code snippet, potentially reserved for future development. This user-centric design of the menu method offers a highly efficient and user-friendly means to navigate the smartphone's multi-factor features, thus significantly contributing to fluid and enjoyable user experience within the smartphone class.
So next is the switch Wi-Fi method. In this portion of the code, we encounter the switch Wi-Fi method, a critical component for managing Wi-Fi connectivity in the smartphone. This method offers a user-friendly interface to control and connect to the Wi-Fi networks, enhancing the overall functionality of the device. Upon initiation, the print details function provides vital phone information, offering users context regarding the device's current status. Following this, it toggles the internet connection attribute, effectively enabling or disabling Wi-Fi. If Wi-Fi is enabled, an example, internet connection is true, the code presents a list of nearby Wi-Fi networks, each with corresponding connection options or an exit choice. The menu is user-friendly, displaying network names and connection details. Users can select a network, and the code employs a switch case construct to execute the appropriate connect Wi-Fi function, presumably handling network connection specifics. Should the user option to turn off Wi-Fi and exit, the method sets internet connection to false and returns to the main menu using the menu function. Conversely, if Wi-Fi is initially disabled, the method promptly returns to the main menu, allowing users to explore other smartphone features. This modular and user-centric design streamlines Wi-Fi management and ensures a seamless user experience while interacting with the smartphone class. And now we will proceed to the connect Wi-Fi method. In this code segment, we come across a method named connect Wi-Fi that's responsible for managing the connection to a specified Wi-Fi network, enhancing the smartphone's usability. When invoked, this method first detects 2% of the phone's battery life, reflecting the power consumption associated with Wi-Fi usage. It then checks if the battery level remains above 10%. If the battery level is adequate, the method prompts the user to enter the password for the specified Wi-Fi network, identified by the Wi-Fi name parameter. If the correct password is entered, it confirms the successful internet connection and redirects the user to the main menu using the menu function. However, if the entered password is incorrect, it provides immediate feedback and allows the user to reattempt the password entry by recursively calling the connect Wi-Fi method with the same Wi-Fi name. In the event of a low battery, the method issues a reminder to charge the phone, prioritizing the device power preservation. This design ensures a balance between user convenience and responsible battery management while using the smartphone class.
The capture photo method begins by printing details, initializing a scanner for user input, and then prompting the user to enter a photo file name and size. It checks if a file with the same name already exists in the photo gallery. If a duplicate is found, it informs the user and opens the camera again. If there's enough storage space and no duplicate, in increments the used storage, add the photo to the gallery and displays a success message along with photo details. Finally, it opens the camera for the next shot. If there is insufficient storage, it alerts the users about the lack of space. In summary, the method captures and stores photos, checks for duplicates, manages storage, and communicates with the user during the process.
In this code section, the display photo gallery methods take center stage, providing user with an intuitive way to interact with their smartphone photo gallery. Its primary goal is to enhance the device functionality and improve overall user experience. Upon execution, the method begins by calling print details function, offering user essential phone information to establish context. It is then present a clear menu offering two choices, one to view the photo gallery or two to exit. The code employs a which case structures to respond to the user's selection. Opting to view the photo gallery trigger the display of gallery contents. Tailored to the code smartphone's brand, it is iterates through the photo gallery list, likely containing reference to the store photos and list them. Furthermore, it provides valuable storage details, including used and available space in megabytes (MB). Upon the gallery viewing, the code smoothly redirect user to the main menu through a call to the menu function. The main menu, while offering pertinent feedback, this is user-centric design that display photo gallery. The method streamlines gallery navigation and enhance the user experience within the smartphone class. The message method within the smartphone simulation code serves as a pivotal point for managing message. It is begin by calling the print details method to display essential phone information and then deduct 2% of battery life. It is checked if the battery level is above or equal 10%. If the battery is in good condition, the user is presented with a menu option through the console. This option including sending message, viewing the box, or returning to the menu. When choosing to send message, the compose message method is invoked to collect the receive phone's number and message content. Conversely, selecting View Inbox trigger the display message inbox method, which is display all received message and their sender. Finally, choosing back to the menu redirect the user to the main menu. Is that event that battery level drops below 10%, a warning is issued, arguing the user changed their phone, and they are directed back to the menu to conserve battery life. This is careful battery management ensure a seamless user experience when interacting with the smartphone messaging capabilities. Method to compose message.
The compose message method in this smartphone simulation code is designed to allow users to craft and send messages. To begin, it calls the print details method displaying crucial phone information. The method then deducts 2% from the battery level, ensuring that there's enough power for the message composition process. Assuming the battery remains above 10%, the user is prompted to input the recipient's phone number in the message content through the console. These details are collected via the scanner class and added to respective lists for phone numbers and messages. After successful message composition, a confirmation message is displayed. Message successfully sent. However, if the battery level falls below the 10% threshold, a warning is issued, emphasizing the need to charge the phone. In this case, the user is directed back to the main menu via the main method to conserve battery life. This compose message functionality ensures that users can efficiently create and send messages while considering the smartphone's battery status to ensure a smooth user experience. The display message inbox method in this smartphone simulation code serves as a crucial component for users to access their received messages efficiently. It starts by displaying essential phone information using the print details method and deducts 2% from the battery level to manage power resources. If the battery level limit remains above 10%, the method proceeds to present the message inbox, clearly stating the smartphone's brand to provide context. It employs a for loop to iterate through list of phone numbers and messages, displaying each received message alongside its sender. The messages are presented neatly with appropriate formatting. After successfully displaying the inbox, the user is directed back to the messaging menu through the message method, ensuring a smooth navigation experience. However, if the battery level drops below 10%, a warning is issued, directing the user to charge their phone via the menu method. This comprehensive functionality ensures convenient message access while considering responsible battery management.
The Play Music method in this smartphone simulation code is a versatile and interactive feature for managing music playback on the virtual device. When invoked, it initiates an interactive menu that allows user to control music playback and volume. First, it checks the battery level and internet connection status to ensure that music playback is feasible. If the battery level is above 10% and an internet connection is available, it enters a loop where users can choose various music-related actions. The menu presents options to play, pause, stop, increase, decrease volume, or exit music playback. Users can also input the music title and singer, enhancing the immersive experience. The method intelligently handles user input such as toggling music, play, pause based on the current state, adjusting volume within limits, and providing feedback on the chosen actions. Additionally, it responds appropriately if the internet connection is off, guiding users to switch it on. It also issues warning about low battery levels and redirects users to main menu when necessary. This dynamic functionality ensures an engaging and user-centric music playback experience, enhancing the overall simulation realism.
Open calculator method in this smartphone simulator code offer user to versatile calculator tool with the energy efficiency and to begin, it also think this method display essential phone information and conservatively reduce the battery by 2%. If the battery levels remain above or equal to 10%, the method utilizes a do-while loop to enable repeated calculator usage until the user reaches the exit. In this loop, users are promoted to input the two numbers and they are the menu of simple mathematical operations, include addition, subtraction, multiplication, and division. Upon selecting an operation, the calculator provides the result with a clear formatting. Users can choose to continue using the calculator or exit the program. The method also verifies if the user wants to use the calculator, again ensuring a user-friendly experience. However, if the battery levels drop below 10%, the method conserves power by returning the user to the main menu via the menu method. This careful energy management strategy ensures the user can utilize the calculator while considering the device's battery status for the seamless experience.
The lock phone method in this smartphone simulation code provides essential phone security and power management features. When invoked, it immediately displays the message "Phone is locked" to alert the user. Through the console, users are presented with a menu containing three options: unlocking the phone, shutting it down, or exiting the program. If the user chooses to unlock the phone, option 1, the method calls the enter password method to initiate the password entry process, ensuring the device's security. Option 2, shutdown, informs the user that the phone is shutting down and triggers the creation of a new phone, which effectively restarts the simulation. Option 3, exit the program, allows the user to gracefully exit the simulation. If an invalid choice is entered, the method issues a warning message and recursively calls itself to present the menu again, guiding the user towards valid options. This comprehensive functionality ensures both the security of the smartphone and responsible power management, providing users with a reliable and secure user experience.
The create new phone method in this code is a straight is a straightforward yet effective way to create a new instance of the smartphone simulation. And so this method invokes the method of the main class with a null argument. In essence, this action effectively restarts the smartphone simulation from the beginning, providing user with a fresh and clear experience. Its practical features, especially after shutting down the phone, or when the user wants to start over without to exit the entire program and the relaunching it. This method offers the convenient way to reset the smartphone state, making it easier for user to explore the simulation repeatedly and engage with it various functionalities without interruption.
The print details method. In this smartphone simulation, code serves as an informative tool to provide users with essential details about the phone's current status. When invoked, this method displays information in a clear and concise format. It begins by creating a visual separator with a series of equal signs, enhancing the presentation readability. Next, it shows the battery status indicating the remaining battery percentage if the battery level falls below or equals 10%. A warning message is added to emphasize the low battery condition. Additionally, the method reports the status of the internet connection, displaying connected if the connection is active or disconnected if it's not. This method purpose is to keep users informed about critical phone parameters such as battery and internet connectivity, allowing them to make informed decisions while using the smartphone simulation. It contributes to a user-friendly experience by providing real-time status updates. The display detail methods. In this smartphone simulation, code serves as a succinct yet informative tool for conveying essential phone specification to users. It begins by presenting the phone's brand, followed by the model and storage capacity in gigabytes. This straightforward approach offers users a quick snapshot of the phone keys characteristics, facilitating a clear understanding of the simulated device. It contributes to an efficient and user-friendly experience by providing essential information about smartphone brand, model, and storage capacity in a concise manner, allowing users to make informed decisions while exploring its functionality next.
In this class main, this code allows the user to create a smartphone object with different constructor options based on their choice, then simulates setting up the phone and turning it on using the switch power method. The specific implementation details of the smartphone class, such as its constructor and the switch power method.
So this is the output of our program. So in the first execution, our program will ask the user to select a constructor. So in the option number 1, we have brand, model, and storage. And in the option 2, we have the model or storage. So for example, the user will choose the option 1. And then the program will prompt the enter brand. So the program will ask the user for the brand of the phone. Then in example, the user want it to be a Samsung brand. And then after that, it will ask for the model. So in example, we choose the S22. Yeah. Then after the program asks the user to enter a model, the program will now ask for the storage. In example, the user will choose 250. And after the program asks the details, the program will now print the smartphone details. Then now the smartphone object is created and will now ask the user to enter the password. So the program we set the password as super shy 12. So the user will enter that, and then after that, it will print that the phone is unlocked and then the battery status and then the Wi-Fi. So as you can see, the battery percentage is at 100% while the Wi-Fi is disconnected. So we have menu as well. So at option 1, we have switch Wi-Fi. Second is camera. Then the third is gallery. Fourth is the message. Fifth is for music. And then sixth is for calculator. And then seven is lock phone. And then the program will ask the user to enter what he or she will like to do to the phone. So an example, the user will choose the number 1 or the switch Wi-Fi. And then the program will prompt the scanning nearby Wi-Fi for Samsung. So the program will prompt the available Wi-Fi that is nearby of the user area. So we have the Globe prepaid Huawei Royal Cable, or we also have a fourth choice is the turn off or exit. So in example, we chose the um, option 3, Royal Cable. Then after we chose the Wi-Fi, the program will ask for the password. So the user will type the password. Then after that, the program will now prompt that the internet connection is complete, and it will also prompt that the battery percentage is at 98% and the Wi-Fi is now connected. Then it will go back to the menu. So in example, we now the user will choose the option 2, camera. And after the user chose the camera, it will prompt the option C, which is for capture photo, or option E for exit. So in example, we chose the C. So it will capture the photo. And then it will ask the user to enter a photo file name. So in example, the file name is photo 1. Then the size is 20. Then it will prompt the capture photo. The photo is successfully captured. And then we and then in example we chose the exit. We will go back to the main menu. Then in example we want to display the gallery. So we will choose the number 3, the option number 3. And then we have the view photo gallery or the exit. So we will choose the number 1, view photo gallery. Then it will prompt or it will display the photos that is stored in the gallery. So as you can see, we have the photo 1 that is captured earlier, and then we have the use storage, which is 20, and then we also have the available storage 230. So, and it will go back to the main menu. So an example, we want to compose a message. So we want to open the message. Then it has an options, send message, view inbox, or back to main menu. So in example, we want to send a message. Yeah, it will ask for the phone number. Then the user will enter the phone number. After the user entered the phone number, the program will ask for the message. We will now type the message. And after that, message is successfully sent. And in example, we want to view the inbox. So it will display the inbox for the phone. As you can see the message from the number that we entered earlier, and then the message that we sent. The next, we will now go back to the main menu. And an example, since we are done with the switch Wi-Fi, camera, and gallery, as well as message, we will now proceed to the music, which is at option number 5. Okay, so we have options here: play music, pause music, continue music, stop music, increase volume, and then decrease volume, as well as exit option. So an example, we want to play music, so we will choose the option number 1. Then the program will ask for the music title. An example, we want to play Everyday. And the program will ask for the singer, which is Ariana Grande. And as you can see, the program will prompt that the Everyday by Ariana Grande is playing, and it will go back to the options again. An example, we want to pause the music. The program will prompt that the music is paused. And then an example, we want to continue to play the music. Music is currently playing. And then next, we want to stop the music, so we don't want to listen. And the music is not currently playing. And then to test if the volume is functioning, we want to play again the music. So it will ask for the music title again. Just we will. Okay, then since we want to increase the volume, we'll choose the option number 5. And then it will prompt that the music volume is already at maximum. So we wanted to now decrease it. So we'll choose the option 6. Now the music is decreased to 49. So since we are done with the music, we want to now exit. And then let's try the calculator. So if we choose the calculator, the program will ask for the first number. So an example, we want it to be number 5. Then the second number is number 6. So it will ask the user to enter the operation. So we want it addition. And it will prompt the answer and will ask the user if he or she wants to use the calculator again. So in our case, we don't want to use it again, so we will answer no. And then since we are done checking all the functions, we will now lock the phone. The phone is locked. Then we want it to shut down. The phone is shutting down and it will ask the user again to create a smartphone object. So I guess that will be all for our program execution.